Okay, we're at the bottom of page 5. We're going to have a look at angles of elevation and depression. So remember, if you feel elevated, you feel up. If you feel depressed, you feel down. And that's the way that I remember it. And the important thing to remember is it's always measured from a horizontal. So from the horizontal, angle of elevation is the angle up. And from the horizontal, angle of depression is the angle down. Okay, and for angle of depression, you often need to put like a dot, horizontal line on your diagram so you can draw your angle of depression. Most common mistake here is people confusing that it's not measured from the horizontal. Okay, and the other thing to be aware of, we'll talk about on the next page, so page 6. So you can see I've got a diagram here with somebody, an observer on the ground, an observer at the top of some building or something. We've got a line of sight between them. You can see from the horizontal, you've got the angle of depression for the observer at the top looking down, and for the observer down the bottom, you measured from the horizontal, you've got the angle of elevation. And you can quickly see, because these two lines are both horizontal, they're parallel, we've got alternate angles are equal, therefore the angle of depression equals to angle of elevation in terms of size. The key difference is that they're in different positions. That's what's different about them. And whatever the question specifies is what you should draw. Okay, even though the angle of depression is not very useful because it's not inside the triangle, still draw it in if the question says so. Okay, and then just quickly add that if this angle here is theta, then this angle will be the same thing, theta. So for angle of depression questions, always remember, draw a dotted horizontal line at the top. Choose which diagram matches the situation. A boy views a kite, angle of elevation of 28 degrees. Okay, this is obviously wrong because it's measured to a vertical. We've got angle of elevation, not depression, so that diagram's wrong, and this one is correct. Okay, we've got a boy, 28 degrees, and then you can see the kite. So C is the answer. Okay, this question. So a lot of these questions are wordy. You have to read through the words and work out what the question's saying. Drawing a diagram is crucial. Security camera is on a wall 3.5 meters above the ground. Angle of depression of the camera is 12 degrees. The camera photographed a burglar's shoe. How far was the shoe from the wall? Okay, and here the assumption is from the base of the wall. You'll often see the word base meaning bottom. Okay, answer to 1 decimal place. So let's quickly draw a diagram. So we've got a wall that's 3.5. Doesn't matter where you draw your wall. We've got a camera shining down. That's my camera shining down at the burglar's foot. We want to work out this distance, how far the foot is from the base of the wall. And we know an angle of depression, so draw my horizontal ... 12 degrees there. And because the angle of depression is 12, the angle of elevation will be 12. So now I'll add the fact that there's a 12 there. I won't omit this 12 angle of depression because that's what the question said. The question said angle of depression of 12, so put in your angle of depression of 12. Now I'm going to focus on this triangle though. So essentially I don't focus on the angle of depression anymore. That's opposite and that's adjacent, so we're going to be using tan. Okay, so tan of the angle 12 degrees equals opposite 3.5 over adjacent x. Okay, multiply by x and divide by tan 12. And put into your calculator. I got 16.46 ... which is 16.5 meters to 1 decimal place. One more question. So from a point A, level with the foot is like the bottom of a vertical pole. And 15 from it, from the foot, 15 from the foot, so 15 from the bottom of the pole. The angle of it to the top of the pole is 63 degrees. Okay, so we've got, I'll just quickly draw the pole. Doesn't matter which side you draw the pole on. We're assuming the ground is at right angles. We're 15 meters away from the the foot, the angle of elevation to the top of the pole is 63 degrees. Okay, it says calculate the height of the pole. So calculate the height of the pole, that's the first thing. And then there's a second thing, so I'll do this part I. And part I, the angle of elevation from A. So what's A? Oh, so A is this point here. To a point halfway up the pole. Okay. So let's work on I firstly. So let's use some trig that's opposite, that's adjacent. So we're using tan here. So tan of the angle 63 degrees equals to opposite, which is h over adjacent, which is 15. I want to work out h, the height. So it's 15 times tan, 63 degrees. In which case we get 29.439 ... which is 29.4. Doesn't say to how many decimal places. I'm just going to do one decimal place. And the unit is meters. Don't forget units. So that's the height of the pole to one decimal place. The second part says find the angle of elevation from A to a point halfway up the pole. So so halfway up the pole would mean that this equals this. And we want to work out the angle of elevation, theta. So this will be the height on 2, okay? So you can use you should still in your calculator have the exact value answer there, and we're going to be dividing that by 2. ... divide 2. So I'd use answer divide 2, okay? Let's use tan theta still. So we're now looking at this bottom triangle. This will be interesting. I want to see if the angle, do you reckon going halfway up the angle is going to be half or it's going to be different? Let's find out. Okay, part 2. So that's opposite over adjacent. So tan theta equals to the opposite. Now I worked out this in my calculator and I got 14.31. 719 ... over the adjacent, which is 15. We're trying to work out the angle, so we use shift tan or inverse tan, 14.719 ... over 15 into your calculator. And it doesn't say what to answer at. Let's answer it to the nearest minute. So hit the DMS button, so 44 degrees, 27 minutes, 33.83 seconds. That's above 30, so it rounds up. That's going to be 44 degrees, 28 minutes to the nearest minute. Okay, just one thing I want to note on this question here. It's really important that you keep the exact value answer when there's multiple parts. If I would have halved 29.4, if I would have halved that, I would have got 14.7 instead of this bit here, and you wouldn't get an as accurate answer. Your answer would be off a little bit when you're finding the angle. So for trigonometry, when you use previous parts, use the exact value answer. Alright, I'll give you a little bit of time, maybe about 10-15 to work on 2.7. See you in the next video.